ratios last term. Okay, hopefully you're going to remember this. What this part here is doing is connecting scale diagrams with ratios. Now, in geography, I'm sure you've looked at some maps by this point, and you will often see that there's a little scale in the corner of the map. Okay, yes? Mm-hmm. We've all seen that?
Key?
In the key somewhere there will be a scale information.
Like 1 centimeter equals a kilometer.
Exactly. Now, the reason that they have to have that is that a map's absolutely useless to you. Well, a real map is useless to you unless you've got that kind of information. Because I could draw a little picture of anything, and if it's sort of scale, we need to know how far these things are. Because I could draw a map of Bermuda. Oh no, I'm not even going to try.
Draw a map of New Year. Draw a horseshoe. You're straight. You're running instructions to go to a party.
All right. So here's so I could draw this road here, and I could say, right, I live here. Okay, but this could be 6 kilometers, couldn't it? Mm-hmm. Or it could be 20 meters. We don't actually know how far it is because I haven't got a scale on there. Okay, so that's a bit of a rubbish explanation, but you know what I'm talking about. Anyway, scales are often written on a map as a ratio, so we need to make sure we understand how these ratios work. So the scale gives the relative size of the length of the drawing to the real life. So we'll always have the map length on the left, and then the real life goes to the right. So the length on the drawing or map comes first. So sometimes they will actually put the measurements in. And if they do, that's great, that's more understandable. Because we can see that each 1 centimetre represents 10 metres. So here's here's another example. So we've got a scale of 1 centimetre represents 50 metres. So each 1 centimetre on the diagram represents 50 metres in real life. So if we saw 3 centimetres, if we measured 3 centimetres on the map, what would the measurement be in real life? And how do we work that out?
Well, I'm guessing since it's 3, you'd be 15 times 3.
Exactly. So remember how when we had our ratios, I got you to write them like this? And then we've got now 3 centimetres. So what you would say here, 3 centimetres. Yes? What did we do from here to here? We multiplied by 3. Remember, it's always multiplying or dividing, not ever adding or subtracting. And so we have to do the same thing here. And so that's going to represent 150 metres. That was okay, wasn't it?
How do you get this 3?
Because they told us in the question that we wanted 3 centimetres.
Oh.
Yeah, you with me? So back to the next one. Again, go back to our original 1 to 50. This time it's 10 centimetres. So what are we doing this time, Maya? Multiply by 10. So we're going to multiply that by 10, and what do we get? 500. 500 what? Meters. Good. Again. Well, that's. You know, it's funny you said that. Remember, this one they've actually told us the units. Okay, so they told us 1 centimetre represented 50 metres. So we're keeping our units as they are in the original ratio. Okay. 4.5 centimetres. Again, 1 centimetre, 50 metres. What do we have to multiply to get to 4.5?
4.5.
Yeah, 4.5. Oh, shush now, I don't want that. So, oh my gosh. So we're now going to do 50 multiplied by 4.5. Oh gosh. At some point today.
225
meters. Yeah. Oh my lord. 225 meters. Oh. Was what? Because you didn't see? Okay. So 225.
Wait,
Let me pause. Right, now these ones are a little bit trickier. Our scale is still the same. 1 centimetre represents 50 metres. But this time, our measurements here are not necessarily in the units that we have here. Which side are we going to put these numbers on, the left or the right?
That's going to be the left.
This one?
Yeah.
Remember, this side here, the left side represents the scale diagram, and this represents the real life. So is this a real life measurement or a scale diagram measurement? Sarah?
It's just that it's 15 meters. It goes under 15 meters because that measures meters and it's also in that.
Yeah, I mean, it's not always going to be the case that because that was meters, that's meters, but it's more likely that that's going to be the situation, yes? So they've said, because the question here says, what would the distance on the drawing be? So that means that we're needing to find out the left-hand side measurement. Does that make sense? So up the top, they said, what would the distance in real life be? So that's why we were able to fill in the left-hand side for all of them. And we were finding the right-hand side, yes? And then for these ones, hang on, darling. These ones, we've been given the right-hand side and we need to find the left-hand side.
If you want me to 15 meters, I found out the answer.
Okay, let's just make sure that everyone's happy with the method. So it's going to be a similar method that we did before. We say, what did we do to this number here to get to this number here? When you're trying to work out what you've multiplied by, you're actually going to be dividing in your calculator. You all happy with that? Yeah. So we would actually plug into our calculator 250 divided by 50 to know what we had multiplied by. And we multiplied by Jade? 5, which is Jade had told me. And so that means that what we're going to do with the left-hand side, we're also going to
multiply by 5
centimeters. And so it would be 5 centimeters. So our answer there would be 5 centimeters. Now, this one's trickier simply because they've mixed it up a bit for us, haven't they? They've given us our measurement in which unit? Sarah?
Kilometers.
Sounded a bit weird. Kilometers. Or kilometers. And so what we have to do now is we have to remember how many meters that is, because we need to try and have it in the same unit. So who can remember how many meters there are in 1 kilometer? Only 2 people out of 9. 3.
I never understood in the beginning. Yeah, I didn't.
Come on then, Square. What? Oh, so you don't know? Oh.
Yeah, I know.
Put your hand up then, you know.
I know. I was going to take a guess.
Oh, come on then, take a guess.
800.
Georgie?
500. I know it starts with a 1.
All right. Okay. My two people that did. Oh, but we haven't not yet. No. 2 people that did know.
It's 1,000.
It's 1,000.
I got it by the second time. That's what I meant.
What? 900 is nothing like 500 is half of 1,000. That's like saying,
It's the same thing.
your name's Jemima. Oh no, I meant to say Sally. Like, it's totally different. 500,000. Jemima. Right, okay, so girls, we do need to remember these measurement conversions. So if you have forgotten that, you need to go back to that little chart that I got you to write. But also remember the way the word is written, kilometre, kilo, means 1,000, okay? So there's 1,000 meters in a kilometre. Right, so going back to this.
But there's 1,000 meters in a
And you wrote kilo.
Okay. Alright, so we've got 1,000 meters. So again, we need to say how did we get from being a 50 to being 1,000? What did we do to our number? 20.
Multiply by 5 by 10.
Multiply by 20, and so we have to do the same thing to the other side. So it's going to be 20.
Wait, why was it 20 again?
Because if you did 1,000 divided by 50,
Oh.
you get 20. So that means that we must have multiplied it by 20 to get to that value. Oh my gosh.
I need intelligent math.
And our last one, 1 centimetre to 50 metres. And again, they've given it in meters, that's nice, but it's a weird old number, it's a little bit trickier. But our method is going to be the same. We're going to do 575 divided by 50 to find our value that we multiplied by. So those are the calcs out. We got 575 divided by 50.
11.5.
Thinking on?
Oh. Fancy.
Oh.
What is that?
That's 11.5.
Fancy numbers. So we don't multiply by that, do we?
Well, no, so remember, we are trying to decide what we have multiplied it by, so to work that out, we do division. Yes? Does that make sense?
So then, yeah, because that would be,
So sometimes the scale expresses a ratio, so the order is still the same. We need to make sure we use the same measurement of units to start of both of them. Now, this is where people suddenly start to not have a clue what they're doing. And it's a shame because it's exactly the same as we've been doing all this time. However, what's happened here is that we no longer have a unit. Okay? So we know that one measurement on the map represents 500 in real life. Now, you may say 500 of what? Well, if we measured one finger width on the map, then in real life it would be 500 finger widths. If we measured 1 centimetre on the map, it would represent 500 centimetres in real life. If we measured 1 metre on the map, it would represent 500 metres in real life. Does everyone understand? So if there is no unit next to it, then you're just going to put the same unit as you've been measuring. Okay? Is that clear? So what's confused you?
the whole part is still just one. The unit, I just don't understand the unit.
Okay, so the unit is just going to remain the same no matter what. So let's do an example and see if that helps. So here they've said on the drawing it's going to be 1 centimetre. So in real life, what do we have to do to our number for this ratio?
So it looks like a cat.
So we've got 1 to 500. So we've got 1 centimetre here. So what we're going to do, we're going to have 500 centimetres. So our answer is just going to be 500 centimetres. We just have to multiply by 500. Now we've got a 2 centimetre. So our 2 centimetre, what are we going to do with that? We're going to multiply that by 500 as well, yes? So that's going to be, what's 2 multiplied by 500?
1,000.
1,000. And that's going to be 1,000 centimetres.
These are calculated straight.
Yes.
So you did 2 multiplied by 500?
Yes, whatever number you have here, on the left, you're going to multiply by 500. That's all you're going to have to do. Now, the tricky part comes in, is that they might say, hang on a minute, I'm not going to ever write 1,000 centimetres.
One too long?
So they might say, how many metres is that?
Oh, sure. 10.
So, how many metres is that? We know that in 1 metre, so think about a metre, yes, like you're picturing a metre about this tall. How many centimetres are in there?
100.
110. Alright, okay girls, come on. We're gonna use our sensible heads here. So our answers are either going going to be probably 10, 100, 1,000, 10,000. So they're all multiples of powers of 10, okay? So your answer is, to me, is going to be either 10, 100, 1,000. Now, we've just got a visual. A meter is about this. Cool. A centimetre is about the width of your finger, yes? Are you going to get 1,000 of those in that height? Is it going to be 10 of those? Well, unless you've got massive sausage mixers, I'm thinking not. So what's our best answer? 100. Right, so do you see how we need to use our sensible heads when we're guessing these things? Okay, you may not know for sure, but that is not going to be 10 fingers. Okay, as I said, unless you've got massive sausage mixers. So what we're going to do to change this to meters is divide by 100. So that would be 10 meters. Okay, so that's where the tricky part could come in these questions. In that they've asked you to find the real life measurement, which we've done. This is the correct answer, 1,000 centimeters. But they may ask you to do further work and actually tell them in a different unit.
Oh, on the tax, right? Would you have to do the simplifying of the 10 meters?
Well, it depends what the question says. So it might say, on the map it's 2 centimeters, how many meters in real life? So yes, you would have to, in that case, you would have to do this bit first, and then change it to meters. But that could be worth 2 marks. So if you showed me that it was 1,000 centimeters, you'd perhaps get 1 mark, and then to actually answer the question correctly, you would need the 10 meters. Okay? So you just have to read the question. But what I don't want you to do is to see, for example, see the word meter in the question and just think that everything is a meter. Okay? Because we've said that it's 2 centimeters, so that's why this must stay as a centimeter, and then we change it if necessary. Yeah? So 7 centimeters. 7 centimeters, what's that going to be on our real map? 3,500. Lovely.
5 meters.
That would be 35 meters. Good job. Yes? So we've got 3,500 centimeters. So that's our first step. And then if we were asked to do it in meters, we would, we would divide by 100 and get 35. Awesome. 7.5 centimeters. 7.5 centimeters.
Big Austin 750.
Alright, well mine didn't have hand up running, so maybe try not to call out. And again, that's centimeters. How many meters would that one be?
37.5.
Good, there you go. You were the one that said you didn't understand and you're the one getting all right on. Now, Abby, awesome. Yes, and squares? Oh yeah, go for it. Yeah, why is that? We answered that again, no one knows. So that's just going to be 500 centimeters. Oh, we didn't change that to meters. What would that be as a meter?
45.
It would be 5 meters. Remember, we're dividing it by 100.
Oh.
Yes? Now, with these questions here, with these questions here, these are quite small numbers, yes?
Yes.
And what we're going to do is we're going to be dividing it by 500, aren't we? Because that's how we work out how many centimeters, or what the left-hand side would be. So, because we know we're going to be dividing the right-hand side by 500, what we probably want to do first of all is change that to be a smaller unit. Does that make sense to you?
Mm-hmm.
Alright, okay, so scrap that. Let's do this as we would do normally. To find out this missing bit here, we would do 15 divided by 500. Yes, you're happy with that? So let's do that in our calcs. What do we get?
0.03.
0.03. What unit would I write next to that? Careful. Remember, our unit here was meters. So what would
Centimeters.
no, our unit here was meters. So what would our unit here be?
Centimeters. Meters.
Meters again. Remember, look, all these units here are exactly the same, yes? So this would be a meter. Now, 0.03 meters a bit trickier to think about that, yes? We would probably think of that in centimetres. So 0.03 meters, how many centimetres is that? 3. So what we're doing this time is we're actually going the other way, aren't we? We've been given a meter, we're finding a decimal number, and then we're changing it to that smaller value. Yes? So 27, what's the calculation we're going to do here to first of all find our initial meter? Yeah, so 27 divided by 500. So who's got an answer for that? Kaya?
0.05.
Okay, that's 0.054 meters.
What?
You said what?
I didn't get that.
27 divided by 500?
Yeah, I got something different.
Oh.
I got 18.5 1.
No, 27 divided by 500 is not 18, darling. Do you think it's the wrong way around?
Never mind.
Okay, so we've got 0, and remember, here I put meters, because my original measurement was a meter. Georgie?
54 centimeters. Oh wait, 0. 5 6.
Got no anything. Okay, so remember to go from a meter to a centimeter, we can multiply it by 100.
Oh, can you wait with it?
That's right.
Let me move it.
We moved it twice. 1, 2.
Oh,
So 100 divided by 500?
0.2.
0.2.
0.2. And what unit am I going to write here?
Centimeters.
Careful, Kaya.
Meters.
Meters first. And then we might want to change it to centimeters. And what's 0.2 meters? 20 centimeters. Good. And then 2 meters. 2 divided by 500. What's 2 divided by 500?
Oh,
No.
that's not.
4 times 10.
It has this weird thing.
4 times 10
Oh.
sort of thingy.
What's that?
I don't know. It's like
Okay, so that is put in standard
it's
form.
over a fraction.
So 0.004 meters. And then how many centimeters would that be?
4.
Careful, you multiply by 100. 0.4.
Wait, okay.
Well, we'll do it times because we can't figure that out. Yeah, I was about to say.
And we wouldn't have one like that. I'll teach you that standard form at some point, but not today. Okay?